This is Advanced Math, Unit 3, Lesson 2. The title is Radians, which is something you learned last year, so this is still review as well as the 3-1 lesson was. Okay, just a reminder that there is part of the Greek alphabet. We use it quite often when we're dealing with our trig functions, and it is theta. We will use that quite often. I'm sure you used it a lot last year, so it's just a reminder. All right, what we're talking about today is the unit circle. And again, this is review. Unit circle you dealt with, so it's just going to be a quick review. What is a unit circle? A unit circle is a circle, so let's draw a circle here, with a radius of 1. Now, if the radius is 1, that means this here is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. Okay, so the radius is 1. What is the circumference? What is the circumference of a circle? Formula you learned in years past, 2 pi r. Okay, so if we are dealing with a unit circle, what did we just say about the radius? The radius is 1, so 2 pi times 1 equals 2 pi. So the circumference for a unit circle is 2 pi. All right, what does that mean? When you had this before, the one we did in class on block day, this was 90, this was 0. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. Those are called coterminal. It can be 60, it could also be called 360, it is the same thing. All right, just like this is 270, it could also be called negative 90. Okay, so that part there was from the other day. So how do we use that for our radians? And radians is just another way to measure angles. We can measure them using degrees, or we can measure them using radians. All right, so what did we say about their circumference? Their circumference is 2 pi. So if you go all the way around a unit circle, when you start, it's 0, and when you go all the way around, it is 2 pi. 0 radians is equivalent to 2 pi radians. All right, so when radians, again, is another way to measure angles. So we're going to be writing radians a lot today. Eventually, we don't write it as much, we don't say it as much, but it is still there. Okay, so if this is 2 pi, then halfway through would be pi radians. Do you agree? I'm going to cover the 0. If this is 2 pi, if all the way around is 2 pi, then halfway through is pi. This is pi over 2 radians, because half of pi is pi over 2. 1 over 2, 2 over 2 is the same as 1. This would be 3 pi over 2. 1 over 2, 2 over 2, 3 over 2, 4 over 2, and 4 over 2 is indeed 2. All right, so you learned this last year as well. 90 degrees is in the same spot as pi over 2 radians. 180 is in the same spot as pi radians. 207 degrees is equivalent to 3 pi over 2 radians. Forgot to put my radians in there. And 2 pi radians is equivalent to 360 degrees. All right. What we're going to be doing is converting between degrees to radians, going from degrees, changing a degree to a radian, and a radian to a degree. So I'm going to quickly give you that conversion factor. Do you guys agree that if these two are the same, 180 and pi radians, the 180 over pi radians will reduce to 1, right? Because 5 over 5 is 1, 10 over 10 is 1. a million divided by 1 million is 1. So if these two are equivalent, I divide them by each other, make a fraction, it's going to equal 1. And would you agree it doesn't matter how I write it? I can also write it like that. Okay, so that is what we are going to be using to convert back and forth. Now you may have learned shortcuts last year, which you can still use. Okay, convert degrees to radians. Convert degrees to radians. Okay, number 1. 90 degrees. Now, without any work, we know that 90 degrees is equivalent to pi over 2. So you wouldn't need any work here. I'm hoping you could, we are going to show work. I'm going to show you how to do it in just a second. But in the future, you could just say, oh, 90 is pi over 2, I'm good, and move on. But I want to show you the work in the easy ones, so when we get to ones that are not memorized like this, it's easier to do. All right, what we do is we convert. I'm changing from a degree to a radian. I'm changing from a degree to a radian. All right, so if I want a radian as my answer, then I want the radians in the numerator. Let me show you what I'm talking about. Pi radians over 180 degrees. Do you agree that's 1? And 1 is the multiplicative identity, meaning if I multiply by 1, I'm really not changing the value. I can change the way it looks, but I'm not changing the value. All right, the degrees will cancel out, and the 90 and the 180 reduce. 90 becomes 1, 90 goes into 180 2 times, and I'm left with pi radians over 2, or pi over 2 radians. Again, it was easy to do without all this fraction business, but you want to make sure you know how to do it. So when you get to ones that are not as easy. All right, 30 degrees. 30 degrees is not one we have up in our picture up here, but it's one you might possibly remember from last year. If not, I'm going to show you how to do it, and then you're going to be like, oh yeah, I do remember that. All right, again, I'm trying to get a radian, so I multiply by pi radians over 180 because I want the degrees to cancel out and I want to end up with the radian as my answer. All right, degrees are gone. 30 goes into 180 how many times? 6 times. So I'm left with pi radians over 6, which is pi over 6 radians. Now, if you forgot it, I'm hoping you remember now. Oh, I do remember Mr. or Mrs. So-and-so saying that 30 degrees is pi over 6 radians. All right, number 3, negative 120 degrees. Okay, the negative is not going to change the way I do things. It's a degree, and I want to change to a radian. So again, I'm going to multiply by this fraction here, so the degrees will cancel out, and I end up with a radian as my answer. All right, degrees are gone. I could also cross out the zeros. And what goes into 12 that also goes into 18? So you're thinking about what goes into 12 that also goes into 18. And yes, it is 6. So when we reduce, 6 goes into negative 12 negative 2 times. 6 goes into 18 3 times. So we end up with negative 2/3 pi radians. Okay, so again, that is converting from degrees to radians. When you're converting from degrees to radians, you want to get rid of the degrees and end up with the radians. So degrees go at the bottom to cross out, radians go at the top because that's what you want in your final answer. Okay, converting the other way, because I did say we will be going back and forth. Convert radians to degrees. Okay, so now we're going from radians to degrees, which means I want the radians to cross out and to end up with a degree as an answer. So I want the radians to reduce and end up with a degree at the top. So my conversion factor, my fraction I'm going to be using is the 180 over pi radians. I'm just rewriting it because it's on the other page. All right, number 1, 4 pi over 3 radians. 4 pi over 3 radians. All right, so what did we say we're going to multiply by? 180, because 180, I'm trying to get degrees as my answer, over pi radians. Now keep in mind, it's not the pi's that I'm trying to get rid of, it is the radians. The pi's reducing is a bonus, but they will not always reduce. Just throwing that out there. The pi's reducing is a bonus, but it doesn't always happen. It's the radians that we're trying to get rid of and the degrees we're trying to end up with. All right, so let us reduce. 3 goes into 180. How many times? 60 times. Everything's gone at the bottom. There's a 1. Pi and radians reduced to a 1 as well. So I'm left with 4 times 60, which is 240 degrees, and everything else is gone. So 240 degrees is the answer. Okay, number 2. Pi over 4 radians. Don't know if you remember that one at all. We are going to do the work, but just quickly. If this is 0 and this is pi over 2, pi over 4 is right smack in the middle. What's right smack in the middle between 0 and 90? What's half of 90? 45 degrees. So pi over 4 should be equivalent to 45 degrees. So let's check if that does work out. We're going to multiply by the same fraction, 180 over pi radians. You want your radians to reduce for sure. The pi's reducing or just a bonus. It doesn't always happen. 4 goes into 180. Go ahead and do the math. How many times does 4 go into 180? And it is 45 degrees. So 45 degrees is your final answer. Okay, number 3. Number 3 is where kids struggle because it looks like this. 1 radian. Now, a radian is a radian. This is still a radian, just like 4 pi over 3, just like pi over 4. Only thing is the pi is missing. And that is possible. It is possible to have a radian without the pi. A pi is not what makes it the radian a radian. It does have it. When you work it out, it's 2 pi. It does have it, but it is possible to measure with just 1 radian or 2 radian or 3 radians without using the pi. What does the degree measure for 1 radian? All right, let's see if we can figure it out. Okay, so what we're going to do is we're going to multiply by the same fraction, 180 over pi radians. Why? Because I want the radians to cross out and the degrees to be in my final answer. Radians are gone. Now this freaks kids out. Oh no, pi didn't reduce. But remember I kept saying up here, the pi's don't always reduce. It's bonus when they do, but it doesn't always happen. Okay, so what am I left with in this case? I'm left with 180 degrees over pi. Now I don't want to leave the answer like that. So 180 degrees over 3.14. 180 degrees over 3.14. Plug it in your calculator if you have your calculators available. 180 divided by 3.14 is approximately 57.3 degrees. So there you go. 1 radian is approximately 57.3 degrees, which rounding to the nearest tenths, we would say that's 60, or the nearest whole, 60 degrees, right? 57. If I'm trying to round up, is it 40 degrees, 50 degrees, 60 degrees? Sorry. I would say that is closest to 60 degrees. So 1 radian, if that's 45, I would say it's approximately about there. That would be really close to 1 radian. And you would have to put your arrow to show you that is the direction you are going in. All right, I'm going to erase that because that wasn't part of the problem. All right, so this is something you should know. It is something you will use. It's not something you have to have memorized, but it's easier if you do. If you have it memorized, it's easier in the long run, but you can also always use this to help you if you ever forget it. Okay, number 4. 3R. I'm going to put it like this. 3R, that's equivalent to saying 3 radians, R-A-D or R-A-D-I-A-N-S. So different ways you're going to see it. No, it's the same thing. Sometimes they won't even write it. They'll just say 3. And in the intro, it'll say the following are radians. Convert them to degrees. And when you read it, sometimes you didn't see and you're like, oh, where's the R? It'll tell you in the intro. The following numbers are radians, or convert the following radians to degrees. Okay, so even if they don't say that or write it, they would have said it in the intro piece of the problem. All right, so I'm still going to do the same thing. Actually, I'm going to give you guys just a few seconds to process how we would calculate 3 radians. So go ahead and think about it. You can hit pause because I am going to come back to it pretty quickly here. So pause, think about it, hit play when you're ready. Okay, 2 ways of doing it. Some kids will do the work that we did here and say, hey, I'm converting, and Mrs. Torres said when I'm trying to convert from radians to degrees to multiply by 180 over pi radians. And the radians crossed out just like she said they would, and unfortunately the pi did not, but that is okay. It's okay if it does not reduce. So I'm left with 3 times 180 divided by 3.14 because the pi's did not reduce. 3 times 180 divided by 3.14. Plug it in your calculator. 3 times 180. If you need to hit pause to grab your calculator, go ahead and do that. 3 times 180 equals, divide by 3.14 is approximately 172 degrees. All right, so think about what I said earlier. 57.3 is really close to 60. So if 1 radian is 60 degrees, how many is 3 radians? 3 times 60 is 180. Is that kind of close to 180? Yeah, pretty close. So what's an easier way of doing it? What's another way kids will work it out? That's what I was saying earlier. If you have this memorized, it goes quicker. Kids will say this, well, if 1 radian is 57.3, because I remember that, then 3 radians is going to be 3 times 57.3 degrees. And you can do that. Again, kids will say, oh, if 1 radian is 57.3, then 3 radians is just the 1 times 3. If they're asking for 5 radians, then 57.3 times 5. So just know either way is correct. I believe when you plug this one in, you get 171.9 degrees. I would accept either one on a test because I know different kids work it out different ways, and I would accept either one. You don't have to write both. It's your choice on which method you use. All right, number 5, 3.2 radians. Hit pause, work it out. You choose. Multiply by 180 over pi radians and work it out like this. Or know that 1 radian is 57.3 and multiply that by 3.2. Hit pause, you decide. Okay, I am going to quickly, I'm just going to use the shortcut. 3.2 times 1 radian is 57.3 degrees. And when you multiply that together, you get 183.4 degrees, approximately. And if any of you did it the other way, you should have come exactly or pretty darn close to that number as well. If you did it the other way, you would have done 3.2 radians times 180 over pi radians. Your radians would have canceled out. You would have had 3.2 times 180. Take that answer and divide it by 3.14. In the end, you would still end up with the 183.4. All right, moving along. Name the quadrant. All right, number 1, 3 pi over 4. Now, don't know how your teachers taught you this last year, so I will check in with them, but I'm just going to show you the way I have my kids do it when when the numbers are not like over here, pi over 2, 1 over 2, 2 over 2, 3 over 2, 4 over 2. What happens when they're different denominators? How do you work it out? So here is a suggestion I have. Some of you already know that this is 1 over 4, and then kind of work your way out from there. So I'm just going to show you, and then we'll see how to work it out. All right, we know this is 2 pi. We know this is 2 pi. We know this is 1 pi. If this is 1 pi, do you agree that 1 pi is 4 over 4 pi, and 2 pi is 8 over 4 pi? Do you agree that 4 over 4 is 1 pi, 8 over 4 is 2 pi? Yes? And it starts off with 0, of course. So I'm going to cover this guy. 0 to 4, what's half of 4? 2 pi over 4. And when they're even like this, you can just count. I'm going to hold off on that 8 over 4. And I apologize, I do have to answer that. Sorry about that. It is after school, almost 5:10, and my family is wondering why I'm not home. All right, 2 pi over 4. Okay, so it's counting by 2's. 2 over 4, 4 over 4, 6 pi over 4, and 8 pi over 4. And let's see if that works. 2 over 4 reduces to 1/2, which that is proper. 4 over 4 reduces to 1. 1 pi is in the right spot. 6 pi over 8, when you reduce, you end up with 3 pi over 2, which again is in the right spot. And then 8 over 4 is 2 pi. Now, you may not need to go through all this on something like a denominator of 4, but when they end up with denominators of 9 or 7, you want to use this method. Okay, so if this is 4 over 4 and this is 2 over 4, then 3 pi over 4 must be in that quadrant right there, which is quadrant number 2. Excuse me, my allergies are kicking my butt. Okay, number 2. Okay, so one more time. 2 over 4, 4 over 4, 3 pi over 4 is going to be in quadrant 2. It's actually going to be right there, right down the middle. Okay, next one. 9 pi over 7. All right. I like to start off right here. This is 0. This is 1 pi, so 7 pi over 7. I don't even write the pi's most of the time. I just put the numbers in. Do you agree that 7 over 7 is 1? So this would be 1 pi. From 0 to 7, what's halfway between 0 to 7? 3.5 pi over 7. And I don't care that I have a decimal within a fraction because I'm just trying to figure out where this number lies. Okay. So it's counting by 3.5. 0 plus 3.5 is 3.5. 3.5 and 3.5 is 7. 7 and 3.5 is 10.5. And what's 10.5 plus 3.5? 14. And 14 over 2, 14 over 7 pi equals 2. Okay, so one more time, what did we do? 3.5, and then 3.5 and 3.5 is 7. 7 and 3.5 is 10.5. 10.5 and 3.5 is 14. 7 over 7 is 1. 14 over 7 is 2. So everything's in the right spot. Some of you will feel like converting is easier, but in the long run, when you're graphing these and you're moving around, you want to get to a point where you do not have to convert. You'll be doing this, but at a much quicker pace. Okay, so this is 7 over 7. This is 10.5 over 7. So 9 pi over 7 would be somewhere within that quadrant. So that is quadrant number 3. And you can just put a number 3 if you don't like to use the Roman numerals. Again, 9 pi over 7 would be somewhere between 7 and 10.5. So it's in somewhere in quadrant 3. All right, last piece. Find two coterminal angles. This is similar to what we did yesterday or block day. Find two coterminal angles. So remember, coterminal angles are angles that end up in the same spot. For example, 80 and 360 are coterminal because they're in the same spot. 0 radians and 2 pi radians are coterminal because they're in the same spot. 270 degrees or negative 90 degrees are coterminal because, again, I end up in the same spot. All right, so when we are doing these, I want you to find one that is positive and one that is negative. Now, do you remember what we did on the lesson on block day when we were looking for coterminal angles when we were dealing with degrees? Let's see if I can find it. Right here, we added 360 and we subtracted 360. Do you guys remember that? We had 45 degrees, and to get a coterminal, we added 360 to get all the way around, and then we subtracted 360 the other way and got a positive and a negative. So we added and subtracted 360 degrees. Same thing here, but instead of adding and subtracting 360, we are going to add and subtract what? 360 is equivalent to how many, to what radians? 2 pi radians. So we're going to add and subtract 2 pi radians. All right. Number 1, pi over 3. Okay, if you remember, I think we did that one on the other side. No, we didn't. But pi over 3 is 60 degrees, so we're looking for two coterminal angles. So we're going to do pi over 3 plus, instead of 260, we're going to add 2 pi. And then we're going to do pi over 3 and take away 2 pi. And why are we doing that? Because pi over 3, let's say, is about here. And I want to end up back here. I would add 2 pi. That gives me all the way around. End up at the same spot. And then I'm going to subtract 2 pi and end up back in the same spot. Okay, so adding 2 pi, I do need a common denominator. Pi over 3 plus 6 pi over 3. I multiply top and bottom by 3, and that gives me 7 pi over 3. And that's one of my answers. And now I'm going to do the same exact thing, but I'm going to take away 2 pi. So I'm going to do pi over 3, take away, multiply top and bottom by 3. So take away 6 pi over 3. And 1 pi take away 6 pi is 5 pi over negative 5 pi over 3. Now notice I didn't write radians. Sometimes I do. Eventually I won't be writing them anymore, but they are still there. Sometimes I don't say them either, but they're still there. Again, over time we kind of stop saying and writing it, but you should know how they work. And that is it for this lesson.